Have you ever wondered how scientists determine the age of ancient artifacts? The answer lies in a technique known as radiocarbon dating. This revolutionary method has not only transformed the field of archaeology, but also opened up new vistas in understanding the history of our planet and the life it sustains. The journey of radiocarbon dating begins in the late 1940s at the University of Chicago. Here, an astute chemistry professor by the name of Willard Libby conceived this groundbreaking technique. Libby's work was built upon the discovery of the carbon-14 isotope by Martin Kamen and Sam Rubin in 1940. Carbon-14, a radioactive isotope, has a half-life of approximately 5,730 years. This means that half the atoms in a sample will transform into other atoms over time. Libby proposed this idea in the journal Physical Review in 1946, and it was further developed with his research group, culminating in more publications in Science in 1947 and 1949. But how does radiocarbon dating work? The process begins with cosmic rays, subatomic particles that continuously rain upon Earth from all directions. When these cosmic rays reach Earth's upper atmosphere, they interact physically and chemically to form the radioactive isotope carbon-14. Living organisms absorb this carbon-14 into their tissues. However, upon death, this absorption stops, and the carbon-14 begins to slowly metamorphose into other atoms at a predictable rate. By measuring the remaining carbon-14, scientists can estimate how long an organism has been dead. The next challenge was to measure the carbon-14 accurately. Libby and his fellow chemists developed techniques to purify a sample so that it emitted no other type of radiation except for carbon-14. They then ran it through a detector sensitive enough to accurately count the pings emitted by the decay of single atoms. A faster method developed in the 1970s used a particle accelerator to count the atoms of carbon-14. Radiocarbon dating can be used on any object that used to be alive, from pieces of animals, people, and plants, to paper made from reeds, leather made from animal hides, or logs used to build houses. This technique introduced a new level of scientific rigor to archaeology, enabling archaeologists to piece together a history of humans across the world. But its impact extends beyond archaeology. Carbon dating has unveiled secrets about how our bodies work, helped us understand Earth's climate, reconstruct its history, track the sun's activity, and monitor Earth's magnetic fields. It has also been instrumental in identifying human-caused climate change, as scientists used it to track carbon sources in the atmosphere over time. In summary, radiocarbon dating, a concept conceived in the late 1940s, has revolutionized our understanding of the world. By using cosmic rays to form a radioactive isotope, and then measuring the decay of this isotope, scientists can estimate the age of ancient artifacts and organisms. This technique has not only shaped archaeology, but also influenced various fields, shedding light on the mysteries of our planet and life itself.